Okay, so in this video we're going to look at solving simultaneous equations where one of those is of quadratic form. And the question here is from a past paper. So it says solve the simultaneous equations, and they're given here. The first one, x equals 3 plus 2y, which is linear, and x squared plus 2y squared equals 27, which is quadratic in form. It actually represents a circle. So the first thing to do here, let me read the rest of the question. You must show your working. So to get all the marks, you must show each stage of what you do. And the first thing we should do is label these equations, because we're going to refer back to them a couple of times, and we need to know which one we're using at any given moment. Okay, so if we look at equation 1, it immediately allows us to substitute into equation 2, because it tells us that x is equal to 3 plus 2y. So we can replace this x here with 3 plus 2y. And I will show you what that looks like. Okay, so I don't want to go too far down the page. There we go. So I've substituted x equals 3 plus 2y in place of the x that was in the original equation. And that step eliminates x, which always makes life easier. If you can eliminate one of your variables, then you're dealing with a much simpler situation. The thing to do then is to expand the brackets. So that's this bit here at the front of this equation. And when we square something, we multiply it by itself. So I've rewritten the bracket there, which then becomes a double bracket multiplication. And there are various methods of doing this. This one I call the face, because it looks like two eyebrows, a nose and a mouth. There's the claw, there's foil, there's a grid method, there's all kinds of different ways. Basically, choose one that you understand and that works for you. Now the result of that multiplication then comes out as 9 plus 4y squared plus 2 lots of 6y. And tidying that up and putting it in order, we end up with 4y squared plus 12y plus 9. So those three terms replace this double bracket and the square here. And you'll see that I've written them there just in brackets, so you can see that that's a direct replacement. What we mustn't do is forget that we've got these other bits lurking about, and you must write those in as well. It's easy to forget them once you've done this kind of manipulation. Then it's easy to just put it back and think that you've done the job, but you haven't, not yet. Following on from that then, I've lost the brackets because they don't really mean anything in this particular case. It was just to show something. And I've added the 4y squared and the 2y squared to give me 6y squared. And the 12y and the 9 stay the same. And then the final thing I've done here is to get from this row to that one, I've taken 27 from both sides. And that's where this minus 18 comes from. What I then noticed was all the coefficients are in the 6 times table, so divided throughout by 6 to make life easier, which gives me this quadratic here. And then we can factorise that using 1 and 3, because 3 minus 1 gives us 2, and 3 times minus 1 gives us minus 3. And so we then quite quickly come to those two solutions for y, 1 or negative 3. In a question like this, what you mustn't forget to do is to then go back and find your values for x. So in turn, we use each of these values for y. We substitute them back into the first equation, which was x equals 3 plus 2y. And we should get out two values for x, one for each of these values of y. Because after all, what you're doing when you solve simultaneous equations is finding coordinates where those things cross. And so you would expect an x and a y value for each of those crossing points. So the solutions to this set of simultaneous equations are the coordinates 5, 1 and -3, -3.